Hey guys, so in this video we are going to see how to import sprites into Unity and how to position those sprites in our game view. So let's start. First of all, let's go back into Scratch just to remember how we import sprites in Scratch. So to import a new sprite, you go to this button on the bottom right corner, select Upload Sprite and select the image that you want to import. As you can see, the image is automatically added to the sprite panel and also to the stage view. Now, how can we do exactly the same in Unity? To import a new sprite in Unity, we do it on the Project tab. And we have different ways to do it. We can either right-click anywhere on the Project tab and select Import New Asset. We can come here to the Assets menu on the top and select Import New Asset. Or we can simply drag the image into the Project tab. Oh, and you can see this is an image that now it belongs to our project. Now, one difference that we can see from Scratch is that when we import a new image into Unity, the image is not automatically added to our scene view. And this is because we can add a lot of assets to our project, but the assets are only being used and are only included in the final game when we actually use those assets on a game scene. So how can we add this image to our scene? Basically, the simplest way is just to drag the image directly into the hierarchy view. And now we have our image on the scene. Now, what is this new game object that was created? Basically, like I said in the previous video, everything in our scene and everything that appears on the hierarchy view are game objects. All entries, each entry is a new game object. Now, this game object that was just created when we dragged our image into the scene is a game object that basically has a component called sprite render. And this is the component responsible for rendering sprites on screen. As you can see, this component has a field called sprite, which points to the image that we just imported. So this is the way when a game object has a sprite render, it is the way that it becomes a sprite, just like we had in Scratch. Now, one thing that we notice is that when we imported our image into Scratch, the image is actually fitting the screen that we had. So when I designed these images, I designed them with the exact size that we needed for our game. So in Scratch, the resolution is 480 by 360, 480 width by 360 of height, and our image fits exactly the screen that we have. Now in Unity, that is not happening. And if we go to our image, if you select the image here on the Project tab, and if you don't have this preview, you have this bar here with the image name that you can just click and you can drag it. It's a preview of the image, and it's also where you have the size of the image. So you see that our image in terms of resolution has 960 by 512. And our screen, we are previewing our game also at 960. So supposedly the image should fit the screen on the horizontal side. But it's not fitting. And why is that? Because Unity basically does not work with the resolution. It does not work in pixels. And this is because when we are creating a game, let's say for a mobile, for example, I think is the best example, when we are developing a game for mobile, each device, or we are building a game for multiple devices, and those devices are going to have completely different resolutions. So when we are creating a game, we cannot be worried about pixels, but we need to have a resolution independent system to work with. Because, for example, imagine that I'm developing a game and I'm working with pixels, and I say that some image, just like in Scratch, when you are moving an object in Scratch, we say that an image or a sprite moves 20 pixels to the right. In Scratch, that is not a problem because Scratch has a fixed resolution. But if we are doing that on a game that is going to be played on devices with different resolutions, if I say that an image moves 20 pixels to the right, it's going to be completely different if the screen is full HD or if it has a lower resolution. So if it had a lower resolution, the image would move a lot more than on a full screen, a full HD screen. Now, so this is why Unity works with a resolution independent system. So Unity works with units. Let's say Unity units. So And that's why when we import our image into our scene view, despite having exact the same resolution as the screen that we are previewing, it does not match the screen exactly. So how does Unity know how to render the sprite with this resolution on the screen? You can see that when you select the image here on the project tab, this image has a field called pixels per unit. And basically what it says is how many pixels in the sprite corresponds to 1 unit in the world. And basically Unity is drawing these pixels, this image at 100 pixels per unit. So now the question is, okay, so how many units is Unity actually drawing on the scene that we are seeing? Because, okay, if it's drawing 100 pixels per unit and the image is not actually fitting the entire screen, it means that, okay, to draw this image, we would need, I don't know, it's 960. So if we divide 960 by 100, it would mean that the screen should have at least 9.6 units. So in this case, it means that the screen has more than 9.6 units. Okay, so how do we know how many units Unity is actually rendering on this screen? And that we can see here in the camera. That's where we define how many units the camera is rendering. And we can change that, or we can see how many units are being rendered here on the size. You can see that the size has like 5 units. What does this mean? It means that, and if you put like the mouse on top of the film name, you can see that the size is the vertical size of the camera view. This is not entirely true. And why is that? Because this is not the entire, because if we look at this description, okay, if we say, okay, the vertical size of the camera view, then it means that the vertical size, that the camera should be rendering 5 units on the vertical axis. And it's not true because this is half of the vertical size, which means that then the camera is actually rendering 10 units on the vertical size. So the camera is rendering 10 units on the vertical size, which means that if we are working with a display of 4:3, if I'm not mistaken, of aspect ratio, it should have 13 something units on the side, and that's why this is not fitting. So all these details just to understand, okay, then how can we make the camera draw exactly the number of units that we need to match the resolution that we have? So if we are using 100 pixels per unit, it means that our camera should be rendering how many units on the vertical side. So if we want a resolution of 720, we need to divide 720 by 100, which gives us 7.2. And if the camera size is half of the vertical size, it means that 7.2 divided by 2 is 3.6. So if we change our camera size to 3.6, now our sprite fits our screen. Now, this should work, but the problem now is that when we are positioning our sprite, and let's, for example, just go back to Scratch to understand the difference. Once again, I'm not saying that all these changes that we are making are the best solution for all games, and when you are developing games with Unity for 2D, this is the solution to have Unity working exactly like Scratch. So when you make the transition from Scratch into Unity, you can continue applying all the same knowledge that you had in Scratch and the way of thinking, and you can apply it in Unity as well. So, but let's go back to Scratch just to understand how we position things in Scratch. So we have this image, this background image, not this one, but this one, the background. And you can see that the background is positioned at, I don't know why it's a 1 here, it's a mistake, it should be 0, and 52 on the Y position. And why is that? Because we want to basically align our image with the top of the screen. And our image is 480 by 255. 56, sorry. I was like 480 by 256. And remember that despite our image having 960 by 512, when we import an image into Scratch, since Scratch max resolution is 480, it always scales down the image to match the max size that it has. That's why the image here on Scratch has half of the resolution that we have on our original image. So if our image is 480 by 256, and we want to align it at the top, we need to make some calculations to get to this value of 52. Let's just go back here Okay, and this is how Scratch coordinate system works, just to remember this. So the origin of the coordinate system is at the center. So we have the position 0, 0, and Scratch has a resolution of 480 by 360, which means that the corners have these coordinates. So on the horizontal side, we increase a number. We have positive numbers for the right, and we have negative numbers when we are moving to the left. And on the vertical side, we have positive numbers when you are moving up and negative numbers when you are moving down. So if I want to position our image at the top, if I want to align our image at the top, then we need to see, okay, our image has 256 divided by, and our pivot point of the image is at the center. So if we need to align the image to the top, we need to move the image half of its height down from the top. And so if our image is 256, divided by 2 is 128, and if our top is at 180, basically we need to move the image 180 minus 128, which gives us the result of 52. So this is just to show you how we position things in Scratch and the amount of calculations that we need to do when we want to position a sprite in a specific coordinate. Now, to do exactly the same thing in Unity, let's see how we should do something like that. For example, let's now go to the coordinate system in Unity, which is exactly the same as in Scratch. So, but we are using the double the resolution from Scratch. So it's not 480 by 360, but 960 by 720. Everything else is exactly the same. So let's just make this calculation for the image, but in Unity. So basically, our image now that we want to position, which is this one, which is 960 by 512. So the calculation is exactly the same. 512 divided by 2, 256. 256 from the top is at 360. So if we subtract 360 minus 256, the image should be positioned at 104, which basically is the double of what we were using in Scratch, but just to make sure that the calculations are exactly the same, the image should be positioned at 104. But now, the problem is that if we try to apply that here in Unity, if I move my image to 104, you can see that the image just gets out of the screen and is somewhere up there. Okay, so why is that? Because remember that we are working with a relationship of 100 to 1. So since we are drawing 100 pixels per unit, we are no longer working with pixels here, but we are working with units. So every time we make this kind of calculation, we need to divide this number by 100 to get the correct position. And actually, let's try it. You can directly do that here on the transform component. You can make calculations directly on the values. So if we divide 104 by 100, which is 1.04, you can see that now the image is properly positioned. And this is exactly what we want, exactly like we had in Scratch. Now, we can make a decision here to just, okay, so let's work with units, and we always need to remember that when we are making the calculations and achieving the value that we want, we need always divide that value by 100. But the other way that we can also do it, and this is just so that it is exactly like Scratch. And once again, this is my only objective when doing all these sort of things. What we can actually do is just change this relationship that we are using when using the sprite. So instead of drawing 100 pixels per unit, we can just change this to draw 1 pixel per unit. And don't remember that you need to change the value here, and then when you change anything here on the these are called the importer settings of the asset. Every time you change any value here, you need to come down here and apply to actually apply the changes. Okay, so now we are no longer working with 100 by 1, but with 1 pixel per unit. So, but now you can see that the image is huge compared to what the camera is handling. And that's because basically the camera is still working with the units that we had before. So instead of 3.6, we need to multiply by this by 360, which is actually exactly half of the resolution that we want. And to position this properly, we should go back to 104, and now it's exactly in the same place. Now, I think maybe this is the best way to make the transition from Scratch into Unity, because right now, when we are importing sprites, when we are positioning sprites and everything, and even making calculations, okay, this is going to move, I don't know how many pixels to the right, to the up, down, whatever, we can think about pixels and not about units and making these calculations. Okay, now I need to think about pixels and I'm going to divide by 100. Maybe this is the best way to have it exactly like it works in Scratch. But the only downside of this approach is that you need to, every time you import a new sprite, you need to change the pixels per unit. Now, one thing, but to solve that, one thing that we can do is to change the Unity default importer settings. I usually don't do this, to be honest, but I was searching how to do it, and basically what you need to do is you come here to the image after changing the pixels per unit to 1, and you can come here to, now I forgot. Oh, here, sorry. Yeah, I found it, sorry. Like I said, I usually don't use this, and I was just searching before I start recording this. So basically what you can do is save a preset and use that preset that for all the assets that you are going to import of this type. So basically you select the asset right here, you can click this button here on the inspector view, select preset, and you have this option on the bottom that says save current to, and this, you can see that it's going to create a new preset for a texture imported.preset file, and we can just save it directly on the assets folder. And then you go here to the preset and add to texture imported default. I think it's something like this. Now if we go here to the project settings, oh, now we have like an empty one. Okay, I made some mistake here. Okay, but this is just like a more advanced thing. I'm not sure if you want to do this or not, but I'll take a look at this later. But basically, when we do this now, every time, supposedly, every time we import a new sprite, it will automatically change the pixels per unit by 1 to 1, and we don't have to do that manually. Basically, it was only because of that. So, let's go back. So, we have our image now imported, we have our image in the correct place. Now we can import other images. And to create our game, our initial game setup, we need to import a few more images. So we have like this graph here, and we have the waves. We have the waves in front and the waves on the back, and we have these curtains in the foreground here in our game view. So let's just import all these images and position the images correctly on the screen. So we have the curtains, the grass, and the waves. Just going to drag all of them. Let's see if the imported work. Yeah, you can see now that all the images are already with pixels per unit as 1, which is exactly what we want. So now we have the images, and to import the images to our, not to import, to add the images to our scene, we can just drag the images. So let's start with the grass. And now we have another thing to take care. You can see that the grass, as we imported the grass into our screen, you can see that the grass is below the background. So we need to talk about layers. In Scratch, we also have the concept of layers. So let's just go back here. So for example, our background is on the back layer, and we have the grass, which is, for example, on the layer number 2. And so let's see what we need to know about layers when we are positioning things. So to position all this, because we have a lot of images and all the images are stacked one after the other to create the effect that we want. So for example, on our back layer, which is called the back layer on Scratch, which is layer number 0, let's say like this, we have the background, so the image of the background. Then after this layer, we are going to have the target images. I'm just going to hide this. So we have our target here. You can see that I have all my layers here. So for example, on layer number 1, we want our targets, and we want the grass after our targets, so in a way that the targets are behind the grass. And then after the grass, we have the first ducks, which I call ducks back. And after that, those ducks, we have the water to cover the ducks. Then we have the ducks front. So we are going to have ducks in the middle between these two bodies of water right here. Then we have the waterfront, and then we have the foreground, which are the curtains. And you can see that I have all the layers stacked here to explain the numbers of each image to what layer we should assign those images to. Now, in Scratch, we can do that with these blocks that we have here. So we have the blocks here on the hooks that allow us to change the layers of the image. So you can go to the front or back layer, and we can also move the images forward or back how many layers that we want. So how can we do exactly the same in Unity? The sprite render, we can do that on the sprite render, has an option here on the additional settings, which are the sorting layer and the order in layer. So we have two options here. And basically what Unity allows us to do is to work with layers as well, but we have two different levels. So first we have the sorting layer. So imagine that we have one layer, and inside that layer, the images might be positioned on different orders. So we have one layer, images on the 0 are at the back, 1 are in front, 2, 3, 4, and so forth. But then we can have more than one sorting layer, which means that we can have different layers, one layer on top of the other, and inside each layer, we can also position images on top of each other. So this gives us two levels to work with. But in this case, we only need a single level, so exactly like Scratch. So we can just use the sorting layer, the default one, which already comes predefined, and we just need to work with order in layer. And so our background image will be at the 0, just like we saw here. So our background is at layer number 0. Our grass is at layer number 2, so that we can have layer number 1 for the targets. So they are between the grass and the background. So let's just change our grass to layer number 1. And now we have our grass. Now let's position our grass. Here is 0. And I don't think we don't need to be doing all the calculations to properly position this. So I'm just going to go check what the values that I used when I created the game for the first time, and we are just going to use those values. I think the main thing about the whole calculations and everything, we already covered that. So let's just see the values and apply it directly. So the graph is at minus 116. Let's just put this minus 116. Let's now import the waves back. And the waves back, what is the layer that we are going to apply? So water back, it's layer number 4. And the position of the waves back is minus 204. So minus 204. And you can see that this image is a little bit bigger than the screen. This is because it was the only way that we could place one water and the other one in a way that they were not like one in front of the other. So we could just displace one of the waters to the right to create the effect that we want. So, and let's import the wavefront. The wavefront is at waterfront layer number 6. And the position of the wavefront is minus 224. So minus 224. Okay, so this is it. Now we have, and we are missing the curtain. So we have the curtains as well. The curtains are on layer, it's the foreground, I call it foreground here, layer number 7. And basically it's 0 by 0. So the curtains are centered on the game scene, on the game view. And so yeah, this is it. I mean, now we have the main sprites that are like the static ones, like this is what the idea here was, just to create the environment for the game, and everything else that we are going to position are going to have like a interaction. So we have the targets that we are going to be instantiating the targets and the ducks and moving them. So this is just like the static environment that we need to create our game. And to finish, let's just do a little cleanup of our project, because one thing that I think it's really useful to start doing right from the beginning is organizing our project in a way that we don't have like a list of things without any type of organization. So one thing that I like to do, and once again, this is just like a personal preference. I'm not saying that this is a convention or that you should do it this way, but this is the way that I do it. And so that's the way I'm going to talk how to organize the project. The first thing that I do is that my own folders, I usually start them with an underscore. And this is because Unity has a Unity Asset Store, which is basically a marketplace where other developers and artists can place their own 3D models and plugins and stuff like that, and you can import those assets into your project. Now, what happens a lot of times is that when you import those assets might not be well organized, and you have different folders and stuff like that. And when you import them into your project, usually those folders get mixed up with your folders, and then after that you don't know which ones were yours, which one was you were importing, and it might get really messy when you are doing something like that. So one habit that I picked up along the way was always starting my folders with an underscore. So in this way, when I import other assets, which usually don't start with an underscore, I can see exactly, okay, these were my own folders that I was using, and these were the ones that I imported. So this is not mine in a way, and I can just move it around and do stuff with it. So this is the first thing. You can just underscore, in this case, the themes. I usually use one folder for the themes. Let's create a new folder. To create a new folder, right-click on the assets, create folder. Let's create a new one for, we could call it Sprites, but I usually call it art. And then, depending on the complexity and the size of the project, I might create subfolders here, one for sprites, one for sounds. In this case, I think we don't need it because it's a really relatively small project. So let's just create an underscore art folder and place all the sprites inside the art folder. And in this case, the texture importer I think it might just stay here at the root level inside the assets. Like I said before, I usually don't use the texture importer. I never used it before. So right now, let's just leave it here and then we'll see. I'm not sure right now if we should place it anywhere else. And yeah, I mean, this is just what I wanted to do. We might also want to start like organizing our scene, but maybe we'll do it on the next video. Oh, we can do one thing also, just change the name of the scene. So instead of sample scene, let's just call it game. And reload, when you change the name of the scene, if you have the scene open in the editor, it just asks you if you want to reload the scene because you changed the name. Then you need to open the scene again with the new name, and now we can see that we are working on the game scene. And so yeah, this is it for this video, and I hope you guys enjoyed it. And on the next video, we are going to start. I think we are going to start implementing the behavior, so instantiating stuff, adding the crosshair, stuff like that, and start to actually messing around with the visual scripting language. So this is it. Thank you guys, and I'll see you on the next one.